Hello everyone, welcome back to Snowflake Compute Layer. Today we are going to discuss about Snowflake Compute Layer and Cloud Services Layer. As part of the Snowflake architecture, we have three layers, storage layer, compute layer, and cloud services layer. So in previous session, we discussed about the storage layer and how the data is going to be stored in a columnar storage and how it is Snowflake maintains in the form of partitions. Okay, so today we are going to talk much about compute layer and cloud services layer. Have you ever wondered how Snowflake can scale instantly, run multiple workloads at the same time, and still feels so simple to use? Today, we will deep dive into Snowflake compute layer and cloud services layer. These two layers are the brains and muscle of Snowflake. So by end of this video, you'll clearly understand what each layer does and how they work together, how they impact performance and cost. So quick recap, already discussed, as we have three layers: storage layer where data lives, compute layer where queries run. How the queries will run? Via virtual warehouse. So cloud services layer where coordination happens between all this. So that's the brain where we always call it as compute layer is called as muscle. So a virtual warehouse, often referred to simply as a warehouse, is a cluster of compute resources in a Snowflake. So a virtual warehouse is available in two types. One is standard, another one is Snowpark optimized. In standard also we have two types, but I'll discuss and I'll show you in the next video when I am going to explain about virtual warehouses, how we can create, what are the options that we have. During that video, I will explain all these types of virtual warehouses. A virtual warehouse provides the required resources such as CPU, memory, and temporary storage to perform the following operations in a Snowflake sessions. Why do we need a CPU, a memory, a temporary storage? Because we might heard this in our old on-prem that okay, while running the full load, we got into temporary storage issue, memory issue, CPU issues. So why do we need all these things is to run or to process certain amount of data or any data which you wanted to process, you need all these things. So that's where the compute layer will help us to run our queries. Okay, so internally to run those queries, it provides CPU, memory, and temporary storage. So you are not going to maintain any of these things, rather Snowflake does for us. So we don't need to bother about those things. So if you wanted to select multiple clusters, you just need to select, create a virtual warehouse with number of clusters that you need, min and max. That's it. When you submit it, it takes care. You don't need to plug in anything or something like that. Okay. So executing SQL select statements that require compute resources, for example, retrieving rows from tables and views and updates, anything. So performing DML operations such as updating rows in tables. How we will update? Delete is an update. Insert is an update. Table, right? So you are inserting, you are deleting, you are updating all these things. So when you are reading, that is called select. So you're not going to do anything, rather you just fetch the data. Even views also will does the same thing. Okay, so now the loading data into tables. So you can load data into tables by using copy into table command, or unloading data from tables. You can use copy into command, and even loading in data into tables using merge into. So via any of these options, you need a virtual warehouse. For example, if you wanted to process or if you wanted to use any ETL or ELT tools to process your data into Snowflake, you need a virtual warehouse. As part of the configuration, we need to provide a virtual warehouse which is used for loading the data from any external sources into Snowflake. Even though you are using external sources, you have to use the virtual warehouses. Virtual warehouses will does the processing of the queries, all those things. If we don't have a virtual warehouse, it will not be allowed to do any of these operations. So that is where it is the muzzle of the system. Okay. Now moving on to the important points, like, so these warehouses, as we discussed, they are independent of each other. Suppose you have ETL, which is using an ETL underscore virtual warehouse. Okay, ETL warehouse, and you have a BI, which is a downstream application which consumes your data for your dashboards and data visualizations. Probably suppose Power BI. So Power BI will has its own warehouse. So they are independent to each other. So there is no problem of, issue on the while fetching the data or while doing any of the inserts or updates or any of these things. So multiple warehouses can access the same data because your persisted data will be same. No resource contention. And here if you see the last point in the key points, warehouse sizes. We have X small, medium, large, X large, etc. Bigger size equal to more compute power. So I will explain you how the X small will consume the credits, small will consume the credits while creating a video on virtual warehouses, how to create those, how to select these sizes. I'll share that. I'll do one video for that. Bigger size is more compute power. So whenever you have a huge requirement, like when you are processing your heavy data into your Snowflake, and you feel that you need a larger warehouse, then you can use it. But eventually it consumes more credits, which means it's a more billing. So we have to be very careful when we are using or when we are creating a warehouse with bigger size. So we need to take the required approvals and then create these things. How queries will run? This is the life cycle of the query. Snowflake query, how it runs is the flow. User submits SQL query. Query is sent to a warehouse. Okay. Warehouse process data from storage, that is from the storage layer. Results are returned. So storage and compute are completely decoupled. Understood? So next one is auto scaling and multi-cluster warehouses. So the simple explanation that I can talk about is single cluster, good for predictable workloads. Multi-cluster handles high concurrency. Okay. So high concurrency means when you have multiple data loads that need to happen or multiple people they need. So you don't even want to take those into queuing, because when you run, there is a queues, right? 8 sessions can open in a single cluster. So if it is beyond that, then they go into queue. So to get out of this, we will better to use multi-cluster. So example, BI dashboards with many users, Snowflake automatically adds and removes clusters. Okay. So based on the load, whatever the defined clusters, that if you define 1 and 3, 1 is the min and 3 is the max. So if we have more queries are coming, so multiple users are coming. So what Snowflake does is, based on the load, it adds one more cluster based on the definition that we have chosen. So once I created that video, probably you can easily understand. So now the auto suspend and auto resume, which is very important for cost point of view. So here, as I told, right? So even in the multi-cluster also, when you define, you can always have an option like auto suspend and auto resume, which will make you, so for example, for a certain time, okay, for every 5 minutes, if you choose that auto suspend, there are no queries which are running, for example, or for every 60 minutes, right? For example. So if you select that option, if you make your virtual warehouse auto suspend and auto resume, when a query comes, automatically it gets warm up. You don't need to do anything. And when there is no query running for 60 seconds, then automatically it suspends. So auto suspend is means warehouse stops when idle. When there is no queries hitting, then it will be in idle state. Auto resume. So starts automatically when query comes. You only pay when compute is running. So that's where Snowflake will say that you will pay for what you use. Okay. So you can keep it idle if you don't use it. So for example, if you have a batch load which triggers for every 1 day, which is every 24 hours probably, and you don't need to use that particular ETL user for any other purposes. Okay, throughout the day, probably you can use one. So you can create that warehouse auto suspend. So okay, so when you don't have any queries running, so it just keep sleep, which is we can call it as idle, and you don't need to pay for till next day for that particular virtual warehouse. Okay. Similarly, auto resume is the moment when the query hits, then automatically it starts spinning up. Okay, and takes care of the queries. So when to use multiple warehouses, example ETL warehouse, reporting warehouse, data science warehouse, no query blocking will happen and better performance of isolating these virtual loads. Okay, so these are the important points about the compute layer. Okay, so we'll do one video on how to create the virtual warehouses, and we can even talk about like there are multiple things or there like how the virtual warehouses uh, policies like standard and economy will work. So we'll show the practical examples out there. Now coming to the top layer, which is cloud services layer. This is the control plane of Snowflake, as we call it as it's a brain of the system. Okay, earlier compute layer is the muzzle and this is the brain of the system. It handles authentication and authorization, query parsing and optimization. So query parsing, when the query hits, so it checks, it does certain kind of optimizations it provides, and metadata management, like whenever there is a data load completed, it takes care of the metadata like the max, min, not null values. All these things will be even query pruning also, and metadata management. And if there is a cache enabled, and transaction management, access control, infrastructure orchestration. So you don't manage it. Actually Snowflake does these things for us. That is the advantage of SaaS. So that is what cloud services layer does. So if anybody asks you that, okay, cloud services layer, can you do some um, like optimizations and all by your own, and metadata management you're going to maintain? Definitely no. Okay. So the query parsing and optimizations. So all these things will be handled by cloud services layer. So one by one, let us discuss about these key responsibilities. So authentication and security. So when user logs in, so and what role that user has been given, and object privileges if there are any assigned. So these things will be taken care as part of the authentication and security. So when user logs in, it checks for the authentication. Okay, the username, password, or if it is SSO enabled or it is MFA enabled. So all those checks and controls like object privileges. Suppose everybody cannot access certain databases, right? All the database you might not need to access. And so similarly, every view cannot be accessed by everyone. So whatever the object privileges that the user has, it will be handled by cloud services layer. And cloud Snowflake follows RBAC, which is nothing but role-based access control mechanism. So we'll deep dive more later. So second one is query parsing and optimizations like SQL syntax validations. Query optimization plan decides which warehouse should execute the query based on the access for that particular, because if you if your project is having 10 virtual warehouses, all the warehouses you might not have access. So based on the access privileges that you have, so it has to run that queries against that particular warehouse. You cannot execute your queries against all the existing warehouses. Okay. So that is also takes care by cloud services layer. Metadata management like table definitions, column info, micro partition metadata, clustering info. Okay, probably we touched on table definitions, column info, but we didn't, I mean, micro partitions also we discussed yesterday as part of the storage layer. But clustering info, like clustering, what is clustering? So clustering on terabytes of data when you have. So clustering is like, for example, you have a table called maybe a transactions table, which is actually huge in size, data size, right? And terabytes of data. And you see certain slowness or performance issues. So Snowflake suggests based on the usage, probably on the date ranges, effective date ranges, or any other certain columns where the most usages on those particular columns are there from a downstream application or from an ETL point of view or from our search point of view also, better you can create, okay, a clustering key which helps to get the data fetch more easily and to do DML operations also more faster than what sometimes it may not work. So that's where we have certain things to consider before we go and create these clustering keys. So this clustering key, creation of this clustering key might need as a, I mean, an extra credits. So we should consider all those things. How to calculate those things we will discuss in while we are explaining about clustering and then search optimization techniques. So that is all about clustering info and transaction management, which is like ACID compliance, time travel, and fail safe. So ACID compliance, most of us know whoever works on the data side. So, and we'll discuss one or two points about time travel and fail safe. So time travel is a feature of Snowflake, which helps us up to 90 days when if you enable that there is a parameter which helps us to declare this time travel up to 90 days. So time travel is means whatever the changes that you do on that particular table, you can get it back up to 90 days. Okay. So for example, 45 days you have enabled, and if you expect 90 days, it cannot come. But from today, and if you have enabled around 90 days back to that table, for example, if you wanted to get 37th day data back, or if you want to see, definitely it can help. Or for example, if it's a timestamp based also. So if you provide the timestamp, it can help you to see the data at that point of time. What is the data in that table? Okay. So that is the advantage of time travel. And fail safe beyond the time travel or any due to any of the issues that you lost the data or your data got corrupted. So Snowflake, we need to provide a ticket for Snowflake. Snowflake will help us up to 7 days. Okay, so up to 7 days it can give us and it can retrieve the data and help us. on that. Okay, but it has to go through the ticket. You have to submit a ticket for Snowflake, and Snowflake team will help us to get it back. That's about fail safe. Okay. Okay, so that's all from the cloud, about cloud services layer and the compute layer and storage layer. So we discussed about as part of the Snowflake architecture. So these three layers are very much important. In detail, we will cover rest of them. Like there are many things that we need to talk about Snowflake, how this data, I mean, table types, how the ingestion will happen, how the orchestration will happen, how the CDs, data warehousing concepts, Snowpark. So there are plenty of things. Keep watching. We'll discuss more in the next videos.